Okay, 2016 AIME 1, question 8. For permutation P equals A1, A2, all the way up to A9, all the digits 1, 2, all the way up to 9, let S of P denote the sum of the three three-digit numbers A1, A2, A3, A4, A5, A6, A7, A8, A9. Let M be the minimum value of SP, subject to the conditions that the units digit of S of P is 0. And let N denote the number of permutations P with S of P equaling M. Find M minus N, or find the magnitude of M minus N. So in here, what's happening is this. I really have three-digit numbers. I'm going to show them this way. So each one has a hundreds digit, a tens digit, and a ones digit. Now, a few restrictions here, but I know that there are a couple ways to get 0 at the end. For instance, if I have 9 plus 5 plus 6, that'll give me 0. And I want to get the smallest value, the minimum value possible, which means I'm going to want the largest place values to have the smallest digits there, and the smallest three digits I have to work with are 1, 2, and 3. So I'll just put a 1 here, a 2 here, a 3 here. There's no reason that the 1 has to be in this place. The 1 and the 2 could flip-flop, and we'll talk about that shortly. But I'll put 1, 2, and 3 like that. Now the next thing I look at is figuring out how to get the 0. And since I want the minimum again, I want to make the ones digits as big as possible so then the tens digits can be smaller. And so I'll just throw in a 9, and there's only really one way to get a 0 if I'm using this 9. Because I can't do 9 plus 1 plus 0. That's not in here. So I'll do 9 plus 5 plus 6. And this will give me a 0 in the ones place. And now that I've used 1, 2, 3, I still use a 4. I've used a 5, I used a 6, I still need a 7, and an 8. So this right here is one possible way to get the minimum value of S of P. And so let's figure out what that minimum value is. 149 plus 275 plus, I guess I can just do it this way. Let me write it how we're used to writing it. Plus 275 plus 386. And I will get 20. 13 plus 8. 1, carry the 2. Wait a second. Did I just mess that up again? Nope, I'm good. Okay. And then 2, 4, 5, 6, 7, 8, 810. And again, the reason is I'm putting the largest digits I can in the yellow ones place and putting the smallest digits I can in the blue hundreds place, and whatever's left over ends up in green. Now, there are a couple of ways this is going to work. So I'll actually, when I was working it through, I found out that it worked out 3 ways. I had 3 possibilities for basically assigning the correct ones digit. So all of the hundreds I'm going to use 1, 2, 3. But now I need to figure out what to do with my tens places and my ones places. And I guess reverse order, my ones places, then my tens places. So here's what happens. If I decrease this to 8 and increase this to 7, so let me do that. So 8, 5, 7. I will not change the sum because I am decreasing this one by 8, but increasing this one by 8. Decreasing this by 1, increasing this one by 1. And when I look at the tens place, I can still have a 4, but I will then be able to replace the 7 with a 6 I'm no longer using, so I'm decreasing this by 1 and increasing that by 1. So really, the sum of this and the sum of this will be exactly the same because I'm increasing one of the ones places by 1, decreasing. It balances all out. So that's another way to add up to 810. If you add these up, you'll see 810. And then there is one other way. So instead of going with 8, 5, and 7, I could also have decreased this 5 to a 4 and increase this 6 to a 7. Again, I'm not changing things, I'm moving one down and another one up by the same amount. And now I've used 1, 2, 3, 4, I need a 5, I need a 6, I've used 7, I need an 8. Okay? So this is just sort of the way to assign numbers to the hundreds, tens, and ones place. Now, each one of these can be permuted a certain number of ways. So the hundreds places can be permuted. So it can be 1, 2, 3, or 2, 1, 3, or 3, 1, 2, or 3, 2, 1, or let's see, what am I missing? 2, 3, 1, or I'm missing one. Well, you get the idea. There are 6 of them. 3 factorial. So I have 3 factorial ways. Let me do that in blue. 3 factorial ways to permute the hundreds place in each of these. Again, same thing with this. I'll do it right this way this time. 4, 7, 8. 4, 8, 7. 7, 4, 8. 7, 8, 4. 8, 4, 7. 8, 7, 4. 6 ways, which is 3 factorial to permute the tens place. Same thing with the ones. 3 factorial for the ones place. And in there, I have 3 arrangements of the numbers in, or 3 ways to choose the numbers for each place. So times 3. 3 factorial is 6. This 3 factorial is 6. This 3 factorial is 6. Nothing evil about this problem. No number of the beast here. I know 6 cubed is 216, so that helped me out. Times 3 gives me 648. And now, just subtract. 810 minus 648. And I get a bunch of borrowing, so 7, 11, 10, 10, 2, 6, 162. Count with questions, and I'll move on to the next problem.